So in this video we will look at problem number 1 from the 2013 AP Calc AB exam, and 1 and 2 on the most recent exams have always been calculator problems. So this is a problem that the graphing calculator is definitely in play for, and the way that we're set up here is that on a certain workday, the rate tons per hour that gravel arrives at a processing plant, it's going to be modeled by this function. Now that's measured in tons per hour, right? And T is being measured in hours, and that function holds from 0 to 8. Beginning of the workday, we know that there are 500 tons of unprocessed gravel at the plant, and over the course of the workday, not only is unprocessed gravel arriving, but the plant is processing gravel at a constant rate of 100 tons per hour. Now in part A here, it says find G prime of 5. Using correct units, interpret your answer in the context of the problem. This is something that's very easy to do with the graphing calculator. It's possible to do this without the calculator until you're ready to evaluate and actually find the value of this. You could take the derivative of this using the chain rule, right? You have this inner function within the cosine function, so you could take the derivative of this manually by using the chain rule, but the calculator has the capability of evaluating the derivative at a point, which is essentially what we want to do here. So I'm going to get my calculator going and we'll proceed. So now that my calculator is all caught up here, I've basically typed this into the y equals screen. So I'm going to graph this function. I'm going to find the value of the derivative from the graph screen. You are going to want to make sure that your calculator is in radian mode, just like you always do in AP Calculus. So just in case you use your calculator in physics or chemistry, make sure you're in radians. And we'll go ahead and we'll graph this, and don't get concerned if you don't see anything on the standard viewing window. We see that this constant value is 90, and if we look at the table on the calculator, we see that when x is 0, we have to have y values that are as high as 135. So I'm just going to manually adjust the window settings. I need to see up to as high as 135. I'm going to let myself see up a little bit higher than that. And our function really only holds for the t values or the x values between 0 and 8. So I'm also going to change that and regraph. And we see a graph that looks like this, which seems like it's going to be able to do the job for us throughout the rest of part A and any other pieces of this that we run into. So let's see. We want to find G prime of 5. And if you're trying to evaluate the derivative at a point, now this TI-83 will not evaluate a derivative for you. It will not give you a derivative, but it will give you the numerical value of a derivative from the graph screen. If you go into the calculate menu, the dy dx feature, option 6, lets you type in the value that you want the derivative at, and in this case we want to know the derivative at the x value or the t value of 5, and it gives us that derivative. And so I'm going to say that G prime of 5 is approximated with, and on the AP Calculus exam, on the calculator section, you always want to round or truncate to 3 digits. So you can write your answer as negative 24.58. I could write it as 587 and cut off everything beyond that third digit. That's truncating the decimal. Or you could use the normal way that you round, and since the digit after the 7 is 5, you would bump that 7 up to an 8. So you could write this as your answer, or if you wanted to truncate it, like I mentioned a few seconds ago, you could write this as your answer, and both would receive full credit as long as you remember to do the second part of part A here, which says using correct units, interpret your answer within the context of the problem. So if we think about what our calculator is showing here, on the y-axis we have g of x being shown, and on this x-axis we have t being shown. Now g of x is measured in tons per hour. So the units of this would be units of y. Since the derivative is a slope calculation, we're going to have units of y, which would be tons per hour, divided by units of x, and x would be measuring hours here. So the units of this answer would be tons per hour, which are the units of y, per hour, which are the units of x. And so using correct units, interpret your answer within the context of the problem. I'm not going to write all this out, but I will go ahead and try to state this verbally. So we have the units here, tons per hour, or tons per hour squared, if you wanted to write those units as if they were units of acceleration. This is basically the rate at which a rate is changing. So what we could say is the rate at which gravel arrives at the plant is decreasing at negative 24.587 tons per hour at the t-value of 5. We'll do the other pieces in other videos.